Across the Fence, the future of science and technology education at the University of Vermont. We'll explore new facilities and a laboratory that puts students on the cutting edge. Good afternoon and thanks for joining us. I'm Judy Simpson. All across the world, there's a demand for workers in areas known as STEM, which stands for science, technology, engineering, and math. STEM workers not only command higher wages, they drive innovation and competitiveness by generating new ideas. At UVM, students working toward degrees in STEM have the latest technology at their fingertips. Across the Fence's Rebecca Gollin explains.
There's a room at the University of Vermont where the possibilities are endless.
The freedom it can be a little overwhelming at first. That was my first reaction when I came here and I started, getting familiarized with everything. But that freedom then gives way to the freedom to design in ways that you didn't think possible before.
It's the Fab Lab, and the tools inside are offering a new opportunity for UVM's engineering students.
Fab Lab stands for Fabrication Lab, and in it we do new age fabrication techniques which are different than traditional, and they are different because a lot of them are additive instead of subtractive. In the old days when we'd make something, we'd take a piece of raw material and we'd remove stuff with milling machines and lathes and things like that. We still do that, but it makes a lot of waste, and we're interested in reducing waste and producing things efficiently.
We have 3D printers, we have high-resolution printers, but also desktop printers. We have a laser cutter and engraver. We have options for being able to solder and build with electronics.
The cutting-edge technology in the Fab Lab allows students to try new ideas and make prototypes that they can quickly modify.
So it pre-processes and makes us like a scaffolding first of the layers. And so if you look at this, like these handlebars, the bicycle style handlebars, this is the scaffolding material, which is actually just starch.
The cool thing about 3D printing is you can build things that are otherwise impossible to build with a
Nicholas Fernandez is an electrical engineering major at UVM. Using the tools at the Fab Lab for his projects allows him to perfect his designs for a lot less time and money than it took in the past.
A lot of this stuff is really nice for do-it-yourselfers. So one of the big things that comes with trying to build your own housing for some stuff is you need it to be precision, and using a chop saw and a bandsaw at your house only gets you so far. And when you're trying to make circuit board cases and stuff, or build your own computer case, it's really nice because it kind of allows me to fully pursue my endeavors.
I've seen a lot of people, students who have taken a Fab Lab course, or just students who are coming in here for senior design, getting exposed to the different tools that are available to them, realize that they can do all of these different things, and then that sort of steamrolls into bigger and better ideas and designs.
Mechanical engineering student Alex Panich used the equipment in the Fab Lab extensively while working on his senior design project.
We had a lot of different, very small, very complicated parts that didn't necessarily have to be machined out of metal, so making them out of plastic was not a problem. And because we were going through so many design iterations and in small periods of time, being able to just send the files over here and get them printed instead of spending our own time in the shop doing it by hand sort of let us spend more of the time on the design process instead of the manufacturing process.
How do you evolve an idea and bring it to that place where you have, in the end, you're having a prototype that's something physical and in the real world? Because ultimately that is really the most valuable skill. You can know how to use these machines, but what are you going to make with them?
Most of the equipment available in the Fab Lab involves new and still evolving technology. Staying up to date with these tools will be a challenge, but the benefits are clear.
You can have a prototype within sometimes an hour on the MakerBots. It's all of a sudden you have your idea and you can look at it and you can show it to people and you can get feedback and you can compare it to other things in the physical world, and that is really powerful.
if you don't have the means to make your idea a reality, that idea often you don't even bother with it. But if you're in a place where you know that if I come up with this design or I have this idea, then I can go ahead and dream big, because once that idea is, in a working state, I can go make it.
In a room full of cutting-edge technology, students are able to dream big. At UVM, I'm Rebecca Gollin with Across the Fence.
Well, thank you, Rebecca. Joining me now are two Vermont educators who are at the forefront of STEM teaching and learning. I want to welcome Jen Carson from UVM's College of Engineering and Mathematical Science, and Joe Chase, who's a science teacher at Essex High School with an emphasis on robotics and physics. Thanks so much for coming in. Now, Jen, tell us a little bit about the future of UVM Fab Lab that was just featured in Rebecca's piece.
Well, our lab, like many other labs on campus, are going to be renovated with a new STEM complex that's being built, and also renovations to the Vody Hall building where the Fab Lab is right now. So we're really excited, and also it's the way that the buildings are going to be connected is going to be welcoming of more interdisciplinary research and collaboration.
And so when is there a scheduled completion date for this? I mean, I know it's sort of in progress.
Yeah, it's over the next few years. Actually, labs are going to be gradually renovated, especially within Vody. We might be looking at some renovations of the Fab Lab over the next 6 months. But the completion date right now is scheduled for the spring of 2019.
Okay. Well, Jen, can you give us an example of how the design process has been influenced by Fab Lab tools?
Yeah, I mean, I think what I see with our students, and Joe, you can comment on this, when you bring them in, is that because it's rapid prototyping and because you can have something right in front of you really quickly, it gives you that freedom to really, as I was sort of saying earlier, is you can look at something and reflect on it in a new way. So we're actually, people's ideas can manifest much earlier in the process and really at a much less expensive price. And it also opens up more opportunities for collaboration because there's that early idea right in front of you. It's really exciting.
And how about for you, Joe?
Well, I think for our students, the ability to have really precise tools to make things with, but also a tool that's easily accessible, is very empowering for students. And they don't, typically our students in the past decade haven't really spent that much time making things. And it's just really refreshing to see a resurgence in our young people making things and being creative and using their problem-solving skills in a more concrete way rather than abstract.
So to actually be able to take it to that next step rather than just seeing things on paper, actually seeing come to fruition.
Absolutely, yeah. Right.
And there's also something that you learn in that transition, I would imagine, too?
Yeah, very much so. Well, the idea is, I think, primarily is believing in yourself and your own abilities and your own problem-solving skills, and to know that you can actually accomplish amazing things.
And so how did the two of you work together, and how do you work with fabrication tools at your schools?
Well, there's a lot of crossover. We've worked together through First Robotics, and also through Champlain Maker Faire, a little overlap at GIV Engineering Institute. How would you describe it?
Well, and also the engineering school has been trying to start a professional development opportunity for teachers called the Vermont Engineering Institute. And so Jen and I have been collaborating on some of the curricular aspects of that, what that might look like. And I think that's really a great growth opportunity for teachers in our state. A lot of attention has been paid towards Common Core, which, justifiably so, but on the other hand, the Next Generation Science Standards, which are also a national body of science standards, have a very direct emphasis on engineering. And it's not really something that's part of the typical professional development for our teachers. And so that's something that we've been talking a lot about and we would like to see grow.
I would imagine that teachers would love that opportunity.
Right, absolutely. It is tough though, because Common Core is definitely, that's what everybody's focusing on right now. But we hope in the next few years, especially with everything that's happening at the university, that gets more attention on how do we bring engineering into the classroom.
Do you find that there are a lot of students who are surprised to find out that this equipment is accessible to them?
Yeah, I think students are surprised initially, but that surprise doesn't last very long. I mean, their thirst for using it is what is really surprising.
Yeah.
So, I mean, at our school, when we first brought the equipment in, it kind of sat not doing very much for the first couple of months, but it didn't take very long before the usage was nonstop, you know, for 8 hours a day, you know, every day of the week. And it's definitely booked up, yeah.
Yeah, and I think one of the things that's very exciting too is you can bring in a lot of different kinds of students and faculty with different interests and different kinds of research. And the machines are just so flexible in what they can produce. For example, we have math professors doing research, we have engineering professors doing research, and we're starting to get some of the art faculty interested as well. I even have someone from Romance Languages who's coming into the lab.
So have the capabilities of these machines created new learning opportunities for the students as well?
Yeah, I mean, it's so expansive. I mean, I think the possibilities we're really just even starting to see what those can be, and that you've got what's really interesting in terms of like facilitating these kinds of learning opportunities, that it is about looking at what the students' interest and passion and goals are, and then they take that in a direction at sort of facilitating them through that process. And I'm sure Joe has the same experience, as you learn a lot from the students because they may be pushing the tools in different directions that you just would have never even thought of.
Interesting. I know you brought an example of something that one of the students or a group of students made.
Yes. I did. Well, you know, I think one of the most interesting things about learning is that you can present a topic or a concept to a student, but it's more profound what they have inside of them and how they connect to that topic. And that's what open source tools like what we're talking about helps bring out what is inside the student. So, I mean, as I was mentioning before, it seems kind of trivial about our concept about a wheel. But if you ask a student to make a wheel, they are often kind of at a loss about how they make a good wheel with practical materials. So this is actually just made out of plywood. And the prototype for this was made out of cardboard that we fished out of the dumpster behind the school. So it's not very high cost. But the concept about being able to make a circle is very challenging. And of course, you know, we see lots of circles, so they got really excited about making them. But yeah, it brings a whole new level in terms of student connection to what you're teaching.
What do you see as the future of rapid prototyping in Vermont high schools?
Well, I certainly hope it grows quickly. And I think that when we talk about 3D printers or laser cutters or technology like that, it sounds like it's pie in the sky, it's too expensive. And I think, though, that the more that we talk about it, the more that we present examples of student work, then we get, institutions to think, well, you know, if we actually budgeted for this, it's not going to take that big of a bite out of what we're talking about. And the access that it provides to students is really going to be off the charts. So I think that's really the main thing, is to get people to think about it, to realize that this is something that they can do for their schools, and to realize it's going to have a big impact on student learning.
Now, Joe, I know one of the opportunities for young students interested in STEM involves the Governor's Institute of Vermont, and you teach robotics at the Engineering Institute. What do students take away from that institute?
Well, again, the idea that the high technology is not out of sight, it's actually within reach, and that's really the main point of what we do. So the things that they'll do, as you can see that we're talking about robots that looks like they're just drawing on the floor at Voti, but this was to simulate planting crops. So again, they're trying to develop prototypes to demonstrate a concept that might be extendable into the real world.
So Jen, how can people learn more about the Fab Lab at UVM?
Well, we have a website that you can get to through, I think we're going to put that website up online. And I think giving us a call. We're happy to give tours, and really welcoming many of the different disciplines on campus to sort of knock on our door and see how we might be of service.
And there's something also coming up called the Champlain Maker Faire?
Yeah, Champlain Maker Faire is coming up this fall, and we really welcome everyone to come, not even just as a visitor, but there's a call for makers out, so even people who are making things in their basements and their garages, this is a great opportunity to share your creation with the community.
Well, I want to thank you both for joining us today.
Yeah, thank you.
That's our program for today. I'm Judy Simpson. We'll see you again next time on Across the Fence.